Hey, guess what? Thanks to all my viewers out there, I have reached the 500 subscriber point in my meager little YouTube career. I'm 501 as of this morning. I want to thank each and every one of you guys for helping me out. I've got 71 videos out there that I know of. There's some more on an older channel that I have. I don't think this doesn't count for that. But I have 500. That was my goal, and I've surpassed that by at least one. I appreciate all you guys, okay? Thank you. I would never thought I even had 500. And it just seems to be getting a little more incrementally up a little bit more. If I would get better with my videos, be a little bit more proactive with my editing, don't talk so much, get down to the point, be a little more brainy and explain things and quit being hyper, I think I might do better, but I am who I am, okay? So anyway, with all that being said, thank you for the 500 subscribers that I've hit. To me, that's a milestone. I thank you from the bottom of my heart, okay? Now, for the 500th episode, I wasn't planning on doing this, but I got bored sitting around drinking coffee and doing nothing. So the 500th episode, or the 500th subscriber episode, we should say, let's see what we can do with this Heathkit transistor analyzer. So, let me move you back a little bit. And let's get you set up on the bench. I know that guy. Wasn't sure which one to start with, so we'll just start. We'll start with this guy right here. It is. There we go. This one is the Heathkit IM-36 Transistor tester. Let's see. That's what's on this thing. Let's get you a little closer over here so you can see what I'm looking at. Alright, narrow you back a little bit. So what do we have here? Here is the adjustment variable potentiometer. The gain, DC beta. Here is the, what do you call that, the meter. You got base current A, gain, let's see. Base current, I guess this selects the meter, don't know. See, gain, base current. Okay, I got you. And then collector current, collector voltage. So I guess this is what you select what you're looking at on the meter. I guess that's what that is. Leakage voltage, short test. Collector to base leakage, diode test. Collector to emitter leakage. ICEO. So you still in the frame, yeah. Here is the small socket right here. Let's see, and then you got big sockets up here, and you put clip leads on or whatever. You got an external bias, collector voltage 50 volts max, leakage voltage 150 volts max. You can select which one of these is internal or external. See, we got polarity, NPN, diode forward, transit off, PNP, diode reverse. Then you got your collector voltage, internal battery, external voltage. So we got 1.5, 3. Let me see something here. 3, 5, 4.5, 6, 7.5, 9. External 50 volts, 15, 5, 1.5. Leakage voltage. Let's see here. Internal battery 3, 4.5, then 6, 7.5, and 9. And that's internal battery. 150 volts external, 50, 15, 5. Leakage 150 milliamp. This is scales 15 microamps, 150 microamp, 1.5 mil, 15 milliamp, and 150 mil, and then 1.5. I guess it's amp. Yeah. Wow. And of course the gain, DC beta, and then you got a gain switch here, low or high. That's what's on the outside of this thing. Looking at that meter right there. Let's turn it off at transit. meter movement, if you watch the meter movement right there, if you can see it, meter movement seems to be okay. Put it in transit, it shorts the meter out. It keeps the meter from going back and forth. So I guess, what can go wrong in these things, huh? Not a whole lot can go wrong in those things. Probably just need to clean all the switches. A little contact cleaner on it, maybe some deox and whatever. So, clean the case on it. So, this is, trying to remember what we found on this when we evaluated these things. Guess I should do like old Shango does, is when he evaluates this stuff, actually write down what he found. That way we ain't got to sit there and go through this whole thing again. But instead of me sitting there running my mouth and all that, let me turn you off for a minute. Take this thing apart to where I can get to it, see what needs to be done, I'll get back to you. Alright, let's see. Got the back battery cover off, so let's see what it looks like. Batteries, contacts look good, shiny. Good, I was hoping I didn't have to clean no corrosion off of them. That's nice, that's good. Thought I had some batteries though, and I can't find them nowhere. Which sucks. Takes D cells, so I gotta go buy $100 worth of them. Sure thought I bought some, but I don't know what I did with them. I don't know. Anyway, let's get to the rest of it and see what it looks like inside. Alright, that thing had about as many screws as a V8. Alright, let me get you pointed down here. Okay, well, it don't look too bad. I think we looked at this before. It's just a little dusty in here. I might take it over to my other shop, my workshop, use the air compressor on it. But I think it's fine. Let's see. It ain't too bad. Could be worse. A little bit of staining inside. Yeah, I'm going to take it over real quick and blow the dust out of it, so I'll be right back. Alright, just cleaning the switches here on the front. And I'm not doing anything special. They actually look really good. I'm just using my good old CRC cleaner. This stuff works wonders. Not getting too carried away, because these contacts look really good. For the age this thing is, they look really good. And the reason I use this again, it does a real good job. It's made by CRC. My viewfinder's upside down. And like I said, this quick drying formula leaves no residue and plastic safe. So that's good. So I'm going to clean this control. Let's say we'll clean this here. I could go in here and deox this. I don't think it's necessary. Don't think it's necessary. We'll get down here and clean this guy. The other thing about it, these phenolic switches here, you gotta be careful what you spray with. Some stuff will saturate that phenolic and weaken the stuff. This stuff, once it dries, this stuff goes, you'll never know what happened. And there's got 3 clusters on it. Need a little washing. That's what's nice about this. Not only is it a contact cleaner, but it's a flushing agent too. So it'll flush any kind of residue or dirt or whatever it might be on those contacts as well. So, of course, I should be doing this in a ventilated area, but I'm not. I bet this was a booger to wire up when they put it together. I'm not sure this was a kit. I guess it was. It just... One more. Okay. Oh, there's one more right here. A slide switch. These slide switches are notorious for being damaged by certain cleaners. You want something that don't stay in there wet, because that these little push buttons, I mean slide switches, can get damaged so easy, and they'll warp. You'll have all kinds of trouble with it. Sometimes it warps out and you get a bad connection, or sometimes it warps inward and then it's hard as heck to move. So you got to be careful of what you spray in these things. There, I think it's good. It leaves no residue. Kind of like deoxit, of course. I like deoxit, but it looks really good. If it gives me a problem, we'll do something a little more. I don't think it's going to be a problem. One problem with this whole thing. I love this cup. I don't drink Maxwell House, but I just love the color of this cup, and I love the little gold on it. I threw this in the microwave the other day and didn't realize. The microwave didn't like it. Just these little gold strips here was popping and snapping. That's what microwaves do when you throw stuff in it. There's a guy on YouTube, I think, that oh, one more switch, the bias switch right here. There's a guy on YouTube that takes and bypasses the safeties on it's actually two guys, bypasses the safeties on microwaves, and puts all kinds of mess in them and turns them on and lets them loose. I hadn't watched his videos in a long time, but that and the guy that does the washing machines and the dryers, he takes and puts all kinds of junk in the washing and the dryers and stuff, and he disables all the safeties, and it's so funny to watch them things just beat themselves to death. Okay, well, let's see what we got. I just like to talk. I get y'all set up here. If I was an expert, I would get all this set up and then hit the go button, wouldn't I? Well, I like you guys to go for the ride. Okay, well, I got the insides clean. Then I'm going to go on the outside of this with some cleaner and wipe all this down. So y'all don't need to watch me do that. So let me get this clean. Let's see how clean we can get it, and then we'll work on. I'll do the case too, and then find some batteries somewhere and test this thing. Okay, I've got the unit, all the dirt and dust cleaned out of it, all the insides. I've cleaned all the switch contacts, took all the knobs and everything off and cleaned them. Cleaned all the smoke residue off the case. So it looks a lot better now. It's at the point now where it's time to test, and got a little problem. I don't have any batteries. Can't find them. I swear I had some D cells. Can't find them. So I can't go any further with this until I get some D cells. Well, I guess in the meantime I'm going to download the manual for this thing and study on it a minute and read up how it works, and I guess kill time till I can get back to the store and get some batteries. So as soon as I get some batteries and put in this thing and make sure it powers up and all this stuff, we'll test it. If there's any kind of calibration that needs to be done, which I don't know, but we'll find out. But so let me see if I can find a manual on this thing and see what the calibration part is, and we'll go from there. All right. bring back. All right, it's next day, or actually the day after. We went to Shreveport yesterday. As you can see, my face is a little bit red. To Shreveport yesterday for the air show that's over there at Barksdale Air Force Base. Well, that's pretty fun. Aviation is not my big thing. I just decided it was something to do, something to go I've never seen before. God almighty, at the traffic. It took us, we were in traffic over 2 hours plus. Then we finally got on the base, got where we were told to park. Then we got, then we had to walk, I bet, a mile to a line that was probably 500 to 800 foot long. Longest lines. It was just people, it was like 6 or 8 lines. God almighty, it took 2.5 hours to get from where we were at in that line to get in to where they told us we had to be in it. People everywhere. God, I don't know. Then it was good. I mean, we got to see the Blue Angels, and we got to see various other, a couple of MiGs, the A1B, I think B1B, the B-52s. Got to go in the cargo plane, but just still so many people. I couldn't even get up in the cockpit. Wait. And I just got tired of waiting. Anyway, I'm not sure I'll do that again. Anyway, back to the project. Got me a set of batteries. I actually found, sorry about that, I actually found the instruction manual. Looked for it day before yesterday when I started this video, couldn't find it. Anyway, I think what we'll do now on this IM-36 is initial test. The test you will perform in this section of the manual will verify that the transistor tester was properly assembled and wired. The adjustments will calibrate the gain control knob for accurate gain measurements. See figure 1. Indication is indicated the tester knows any of these. If indicated results are not obtained in any of these tests, refer to the case of difficulty section on page 41. Initial test. Okay, so let's quit watching me. Let's see. I guess I'll put y'all right there. Let me put my viewfinder where I can see. Zoom y'all in just a little bit. We'll turn that a little bit. Let me get y'all set up. Let's see, my battery is. I think for this though, I'm going to have to be looking at the screen. So if y'all don't mind being at a little bit of a bye. We have some skip coming in this morning on 2 meters. Hearing stuff from all kinds of places. Anyway, set the polarity switch and the transmit off. So that's this button, this knob right here. Alright, and then set all other rotary switches and controls to their full counterclockwise position. Okay. There you go. I don't know how you set a switch, but anyway. Alright, takes care of that. Alright, polarity switch, pick up and shake the transistor tester from side to side to make sure the meter pointer swing on both sides of 0. The meter movement should be well damped, hard to swing from the polarity switches. Now repeat the above step, polarity switch to NPN. Meter should swing more freely. I think we did that the other day, and of course it does. Alright, repeat the above steps, set the polarity, I can't talk this morning. Set the polarity switch at P&P. Note the meter scales are marked 15-0-15 and 50-0-50. I guess we need to put the batteries in this thing. How about we put the batteries in this thing? I just happen to have some. Unbelievable how much batteries are now. I got Energizers. I got anything but Duracell. this is K5RUS repeater. Code is built 12713. I don't know why Duracells are even on the market anymore. As bad as those things leak. They don't make them like they used to. Everything made in China, cheap. Alright, let's see if I can figure out how to do this. Couldn't remember how many of these things took. I just got the big 8-pack, hoping I had it right. Kind of like loading a shotgun. Use the 7 D cells. So I got one left over for one of my ohm meters. Or, excuse me, one of my BOMs. I can turn this back around without knocking the battery loose. Alright. Somewhere I thought there had been a pointer adjustment on here. Let's see, I'm going to adjust that real quick. It ain't quite 0. There we go. Yeah. Alright, well, what next, y'all? It's collector voltage and leak voltage switches. Note the meter scales are 15, 0, 15, and 50, 50. So if the top scale here is 15 to 15 with 0 in the middle, 50 to 50 with 0 in the middle. Voltage to be read on one of the two scales, as indicated by the position of the collector voltage or leak voltage. Collector voltage or leak voltage. Okay, now what? The first position, 1.5 of either switch. Let's see, right here. Here we go. 1.5, first position of either switch. Voltage reads on the 15 by 15. Okay, by moving the decimal point one place to the left. In the next two switches, switch position 3 and 4.5, the 50-50 scale, so that would be 5 and 5, I assume. For the next 3 position switches, voltage is read directly on the 15 scale. Okay, raise lever switch B, collector voltage, to the collector voltage position. The meter pointer should deflect to the right and left, indicate 1.5 volt. How about we put this on PNP and do that again? I'm not seeing nothing. I ain't seeing nothing. Oh, let's go to internal batteries. I ain't seeing nothing. Don't ask me. Set the polarity switch at PNP. Raise lever switch B to the collector voltage position. That should indicate 1.5 volts, or slightly higher if fresh batteries are installed. I'm not seeing nothing. What's up with that, y'all? What did Sam do wrong? What Sam did wrong? It should be working. Delays, delays. Let me make a quick sanity check here. I'm just wondering if these battery connections need a little bit of cleaning up. Let's try that. Put it back on PNP and I'm going to push. They look clean to me. I didn't think they needed cleaning. No, I'm not getting anything. Well, let me troubleshoot that and I'll come back and tell you what I found. I don't know how to... Well, been a little time. I've been about 5 hours. I've been working on this thing, trying to figure out why that meter would not move. Come to find out, it's the meter movement itself. Because I could not find it. I traced circuits and circuits and circuits till I was blue in the face trying to figure out how this crazy thing was hooked up. I've never liked meter circuits. They've always just mystified me. Just the way they run through all the wafer switches and all that stuff. It always just confused the hell out of me because it wouldn't just give me a clear path where to go to do this and that. Anyway, so I finally just put a voltmeter on across the meter leads and started playing around with it. And I've got, let me see if I show you. You can get all this stuff in frame. Let's see here. Let me get my other voltmeter. Well, I've got about 0.4, a little about 0.4 volts roughly, or 400 millivolts should I say, on this thing. Right now it's at, it's showing about 12 volts, and about 0.413 volts. If I tap the meter, what happened a minute ago, this thing was not going to act up to save my life. I could make this thing act up like crazy a minute ago. Ain't that something? There we go. Sorry about that. I would tap on this meter and it would drop down and the voltage across the meter would go up. That told me there's something loose inside this meter. Now I can't make it act up for nothing. Ain't that the way it goes? I've been fooling with this thing most of the day, just trying to figure out why I wasn't getting the proper meter movement. Now it ain't gonna act up. Ain't that something? There it goes. See? 460 millivolts. Look at it. I don't know why I'm losing DC voltage all of a sudden. That's crazy. I don't know why I'm losing my voltage. don't know. Oh, because my meter lead came off. Such a dummy. Sorry about that. Anyway, see, the voltage went up feeding the meter, but however the voltage dropped down on the meter. That indicates something internally with this meter, because as the meter begins to work, it puts a little bit of load across that those terminals. It'll drop that voltage. See, 460 millivolts now, and it's dropped down about 3. So there's something internally wrong with that meter, which is not the end of the world. I've got that other tester that I can rob the meter off of. That's what's wrong. It took me half a day to figure that out. Half a day. I had other things to do. So we're going to turn it off in transit mode. Take the meter out. We got nothing to lose. Take the meter moving out. See if we can identify a problem. It's fairly easy on this one around here. Taking a meter moving out is not for the faint of heart. I've never done it before, and that's something that on obtainium, then I wouldn't recommend it. I actually suspect a cold solder joint. I mean, I trace voltages. I traced circuitry and voltage because I was sure that was a loose connection or a bad solder joint. But I could not find how the voltmeter just, it's got so many switches in here. It's almost like a tube checker. It's got so many switches in it. Trying to find the path between the battery and the meter was a pain in the butt. I never did quite find it. Pretty sure it's got circuitry involved is the voltage divider network and the current set and the bias set. Anyway, there is the meter movement. So somehow or another, let me turn this off a minute and clean my bench up. Be right back. Alright, I have the meter out. Have the meter out, as you can plainly see. So I'm going to pull the face off of this because there's no screws around it. So you got to pull the face off first. Then when you do that, you got to take these nuts off right here off the back. You got to be very careful. Take your time with that. Anyway, I am going to get me a small screwdriver. Get one of my little cobalt precisions here. Alright, let's quit looking at me. This ain't the Sam Hunter show. Put you in about like that right there. So anyway, get my cobalt screwdriver assortment. Figure out how to open it. There we go. Alright, let's see. Put my close-ups on. Very carefully. Little pry sections in here. Pry it apart very gently. Take your time. You ain't in a hurry. Nobody's going to take it from you. Got a little ball training session going on outside there with one of my granddaughters. There we go. Very, very careful with it. I gotta pry the bottom apart, I think. Just about need a microscope for this. Let me change glasses. Put on my nerd glasses. When inspect, just bring it up a little bit. When inspect this wiring in here.
Huh? What you just put up by your feet? On this side, back side.
Found the problem. Oh my. These meter movements sometimes have little bitty microscopic wires. They are smaller than the human hair. And, whoops, sorry about that. I'll show you where the problem is. Let me get this focused in on you. Gonna focus, 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 focus. Anyway, right here, right there to there is where the problem is. Still a metallic connector that goes from here to there, and it is broke off. So that's what was happening. The meter movement was getting connections through. In other words, that's a shorting tab because it's, in other words, it's bypassing the bearings. You can see it almost. That little dude right there. It's come on. It's broken off of this main part. So let me get that off of me. I got to think about this a little bit, so I'll bring you back. Okay. This is a funky little meter. We got a storm brewing over here. Pardon the nerdy looking glasses, but let me get this set up for you guys if I can do this. Okay, what I want to do, you got to be delicate with this. Watch that meter as I bump that. See that voltage changing? I just tap on the meter and it goes all over the place. Now, if I tap right back here where this meter movement actually connects to the power voltage coming in, fluctuates. If it does the same thing if I mess with the front side here, I'm not sure what's going on there, but I am going to spray them areas with a little bit of contact cleaner. I'm trying not to get it on this meter movement, so wish me luck. I ain't sure what'll happen. I ain't never done this before. Whoa! Move this back and forth. Actually, I think it made it more sensitive. Okay. It's the damnedest thing I've ever seen. And we'll spray the back of it just for fun. My voltage just dropped actually down to 15.6, 15 to 16 millivolts. Meter's actually gotten more sensitive. I don't know. I'm beyond, almost at my capacity to see this stuff. I will show you, but basically it's going to be hard to see. Actually, I think I broke the meter, which is why I was rather more sensitive. I think I actually broke the stupid thing. Yeah, I think I've damaged the meter. It's just so, it was bad anyway. Let me play with it a little bit. Y'all don't need to see me sit here screwing around with this. I'll bring you back for anything worth talking about. Well, bad news on the IM-36. Definitely a bad meter movement, and me trying to repair it made it even worse. It's totally unusable. The meter is dead on arrival. Nothing I can do with it. The meter out of the other Heathkit that I've got is not the same kind of meter. This one here that's on this IM-36 is a center off meter. In other words, center is 0. The other one that I've got is a 0 to the left. In other words, it's a standard meter. So, until I find another meter, nothing I can do with this. That's a shame. I've spent almost a full 8 hours on this thing total, and heart's breaking to come upon this problem. So, anybody knows where I can find a meter for an IM-36 that actually works, so let me know in the comments. Anyway, hell of an episode for 500th subscriber celebration. I wish it could have been better, but hey, that's what happens These things have been setting up Lord knows how long and subjected to who knows what. So that's what happens. So anyway, that's it. Thank you guys for watching. Thank you guys for the 500 plus subscribers. It's been a blast. I hope we can make 1,000, and hope that would be interesting too. So anyway, thank you guys, and if you haven't subscribed, hit the like button down there somewhere, in the doodly boodly, and subscribe. And yes, that was thunder. Another one of them wonderful spring storms. Anyway, have a good one, guys. Thank you. Talk to you later. Bye.